saw it. Like this morning, I heard 6, and then literally the next person that told me 10. You just said then it was 14. You just said 15. It goes up every single time I hear it. Yeah. Are you serious? That's like that's a lot of snow. But usually, like if you cut it in half, you're okay. Even half of that would be a heck of a lot. All right, so we got. Shh, quiet, please. We have binomial. We had 4 requirements, and we have geometric, and there's 4 requirements. 3 of them are the exact same, and the 4th one is the one that allows you to tell the difference between them. So we'll do the 3 that are the same first, and I'll put the 4th one, the different one last. So you still need a fixed probability. You still need a independent events, which means like one thing doesn't affect the next thing. So if I roll a die and I get a 2, it doesn't like make a 2 more likely the next time. If I flip a coin and get tails, it doesn't make tails more or less likely the next time. You still need a clear yes, no, or success, fail. What was the 4th one in binomial, though? A fixed number of tries. Like we knew exactly how many times we're going to do it. We're going to shoot 5 free throws. We're going to roll 10 dice. We're going to count 5 days and see how many times Maui shows up. Whatever it was. This is no fixed end. We keep going until we get 1 success. So you're going to roll a die until you get a 3. We're trying to figure out how many times that would take. Like, what's the probability of getting the first roll, second roll, third roll, fourth roll? But once you get it once, you're done. The experiment's over. So once Maui shows up to school, the experiment's done. Move on. So the formula is on the board too, and those will be up there for your test. All that stuff will be up there. Well, sure, I'll leave it all up there. Probability x equals k is q to the k minus 1 times p to the first. You don't necessarily need the first, but it helps me remember like there's 1 success. So the q stands for probability of failure. The p is probability of success. K is the trial number of our first success. Yeah, you were gone like most of last week? No? Yeah. You were here. So why were you asking about school? Oh, so you weren't like missing stuff. You were okay. Yeah, I was like, wait, where are you going? Okay. It was just Logan. I mean, nobody really cares about Logan anyway. So we're good. Would you have watched the videos? Right. Were you sick? Was it bad or just decent? Okay. Okay. So how does the formula work? So I don't even know if you know what I mean by that. But what I'm saying is, we're going to get our first success on the fourth trial, let's say. Like I'm gonna roll, flip a coin until I get tails. And I wanna know like what's the probability I get tails on the fourth roll. If my first success is on the fourth roll, what happened on the first three? I failed. If my first success is on the 10th roll, what happened on the first 9? I failed. If I make my first free throw on the third attempt, what happened on the first 2? I failed. So this is you fail every single time except the last one, and then you succeed once. So it's fail all except one, succeed once. Fail is such a harsh word, but you know what I mean. Why is there no n in the formula? Because we don't know how long it's going to take. I might make my first free throw on the first attempt, second attempt, third attempt. We don't know. We don't know. Mean and standard deviation are on the board, and they will be during the test also. I'll put like a little cardboard box around Peter's desk so he can't see the formulas, but everyone else will be able to. You just get a cubicle, you can't see anything. That's what we should have for tests. That's what we should have. I should invent that. Desks that like fold into cubicles, so you can know, but then the teacher can see what you're doing. Two-way mirrors. Yes. All right, you're in on my project. You get a cut.
Add a little slide. Pull up for that.
Yeah. We gotta work on this. All right, screw stats. Let's just start building a company. All right, so for these 7 right here, remember binomial is a fixed number of trials. Geometric, you're looking for the first success, but just the first one, not like the second or third. So go ahead and go through those 7 and tell me if it's binomial, geometric, or neither. I'm sorry, I didn't mean to scare you. The plan is test next Tuesday, but I heard we're gonna get 400 inches of snow. That's what by 7th hour. That's what people are gonna be saying. We're supposed to get 24 to 36 inches.
Probably not gonna get
I know, now that we did.
Yeah, no one
It's
gets
how
really
this
good
weird
at
Memphis
it.
nowadays. We're not gonna get one.
And they'll still be like, you're still coming to school.
No, I'm not risking my life.
Sorry, I'm not coming to school.
So you don't get plowed.
No, we don't get any. So like, even after it's been a few days, it still sucks. Like it's
Right.
dangerous.
It doesn't plowed, it's like patted down, it makes it slick.
Exactly. Plus, it's like dirt. It's already not the greatest.
It's not stable.
It's not stable to drive on. So dirt plus
Right.
wood is very accident.
Yeah, I know. My mom was like,
Rising.
So you get your personal snow days?
no.
Did you come? It was pretty bad a couple days last.
I was here today, right?
Was that last week we had like a couple days? Or something? The week before.
Oh, are you talking about like Tuesday morning? It was snow Monday night.
Yeah, yeah.
Monday.
Yeah.
I know for basketball.
No.
Yeah, I did.
Okay,
Like, you did not have it. And I was riding.
so number 1 is like kind of an illogical. Are we good or no? Like, can I also told you we're gonna flip it 10 times, so that's neither because it's like contradicting itself. Does that make sense? Why it's neither? Like saying two different things. Roll a die until I roll a 4 or a 5. So in this case, a 4 or a 5 is considered success. I'm gonna roll until I succeed. That's geometric. That's like the definition, the classic geometric. Number 3, flip a coin, and we're gonna count how many flips it takes to get 4 heads. We could do that. That is like a legit problem in a higher up stats class. But in geometric, it's just the first time we're looking for, not the fourth time. So this is neither. Because we don't know how many trials, so it's not binomial. It's not just the first success, so it's not geometric. Number 4, where we're drawing 8 cards. So it's a fixed number of trials. We're going to count how many red cards. That's a clear success or failure. But what's the problem? This is neither. Why? Without replacement. So if you're not putting it back, what's changing every time? Is the probability, right? So now you got 51 cards, then 50, then 49. Shoot 10 free throws. So that's a fixed number of trials. Let X be the number of misses. So here we're just calling a miss success, which you can do, which is weird. But this is binomial. I didn't tell you, so is that why you put neither? I mean, that's fair. But okay. The scenario, if I told you, probability of success is binomial. Is that fair? Yeah, no, that's fine. I get that. Let's say B equals 0.36 or something. Because you were like, wait, does it change every time or not? Maybe. Yeah, that's fair. Is Maui on fire or not? What are we talking about? So, shoot free throws until you make one. So what I was going for here was geometric, because we're looking for the first success. Draw 4 cards with replacement, so that keeps the probability the same, right? And so then we got a fixed number of trials, and we're going to count the number of aces. So what's that one? That's binomial. Questions on any of those? Alright, we're going to do these by hand. So, like without the GMF, PDF, and CDS, like without the calculator commands. So I know my formula is the probability x equals k is q to the k minus 1, because I'm going to fail every time except for 1. Times p to the first. Yeah, I think it makes more sense with numbers than with letters. So if I want the probability that I got A through E for every item. So what's the probability of success? 0.2. The teacher wants me to take the test until I get my first question correct. And then you just multiple choice, you're guessing. When you get one right, you get to leave. And I want to know the probability that you get the first question that you get correct is the third question. So if that happens, what happened on the first 2? You failed. What's the probability of failure? 0.8. How many times did you fail? 2. What's the probability of success? 0.2. How many times did you succeed? That's all it is. Fail twice, you succeed once. So, I mean, really, if you want to, you can go 0.8, 0.8, 0.2. 0.8 to the second times 0.2, so I get 0.128 for my answer. So that would be the probability of x equals 3. What do these two numbers have to add up to? The k or the 3? What do these two numbers always have to add up to? 1. Probability x equals 0. What's the probability that I get the 0th question correct? Is that possible? Can I get the 0th question correct? Let's check out this left device because this is 0. It's impossible. You cannot cannot succeed without trying.
Don't write that down. That could be someone's senior quote, right?
Isn't that deep right there? You cannot have a success if you have not tried. Maybe the boys basketball team should take this under consideration. I don't know. It's no guarantee of success. So in a binomial, like I'm gonna flip 5 coins, can I get a 0? Hey, listen. In a binomial, like I'm gonna flip 5 coins, count the number of tails. Can I get a 0? Can I get 0 tails? Yes. In a geometric, could I get my first tail on the 0 at the top? Cannot. So in a binomial, 0 is possible. Binomial has 2 zeros in the word, right? Can you spell it? Binomial. Geometric doesn't have any. I don't know if that helps. Find the probability x is less than or equal to 2. So it could be 2. It could be 1. Do I have to worry about 0? I cannot get my first success on this 0 at the time, right? I can't succeed without trying. So I'm just going to worry about these 2. Well, if the second trial was my first success, how many times did I fail? Once. How many times did I succeed? Once. And then probability x equals 1, if I got my first success on the first try, how many times did I fail? 0. So this is just, like if you want to write point into the 0 you found. But you can also just write 0.2. And then we have to add these up. So this is 0.16 plus 0.2 equals 0.36. Probability x is greater than 2. So my possibilities are 1, 2, 3, 4, 5, 6, 7. It actually goes on forever. Like it's possible my first success doesn't come until the 100th try. So greater than 2 is I'm looking for all of these. And it's actually impossible to add them all up. So you know. By the time you get over here, the numbers are so small it won't matter. But I'm not going to type in I'm not going to write the formula for 3, 4, 5, 6, 7, 8, 9. I'm going to find 1 and 2, and then what am I going to do with that? I'm going to subtract it from 1. So didn't I just find this in the previous question? So can I just subtract that from 1 and that's my answer? So you guys try E. So again, that notation, that means between 2 and 4, are you including the 2? Yes. Are you including the 4? My phone says there is a 100% chance of snow on Wednesday. But 3 to 5, that's not. But it says like 1 inch Tuesday night, 3 to 5 Tuesday day, 3 to 5 Tuesday night, 3 to 5 Thursday night. So we have to add those together as we would do in stats. Probability. Who'd you guys play Friday? Here or there?
How do you call Shit, my stomach was. Why would you eat more? McDonald's is just so bad for you. Oh yeah.
Did she get points for that?
That's when I was like, oh, what's wrong with you? It looked like you were crying. It looked like you crying because it was so
So you got that? We're good. If you got a question, let me know. Sign it up and figure it out. But we're okay.
Like that just sounds like so.
Yeah.
I don't know.